This conference will now be recorded.
All right, hello everyone. This is Brian Gockel here, Office of OBS with the TowerS team, welcoming you to the weekly Satellite Book Club seminar series. The title of our talk today is LightningCast Evaluation, Description, and Initial Observations. Our presenters today are Dr. Chad Gravelle, John Centennial, Ted Ryan, and Steve Zubrick. Chad's also going to be facilitating for us today, so we welcome the presenters and Chad. But before we begin, just some of the usual reminders. As you may have heard a moment ago, this session is being recorded. We will have the Q&A at the end of the presentation as usual, and we encourage your input from everyone, but in particular from those from the regional and field offices and national centers. As usual, please post your questions in the chat. The TowerS team here will queue them up for Chad, our facilitator, and we'll go through them at the latter half of the talk as usual. Most of you are already doing this. We encourage you to and request that you sign in with your full name so we know who's attending so that we can follow up with you if you have any questions or comments. We know exactly who they're coming from. So that's quite helpful. We, as usual, are looking for future presenters. Contact the TowerS team. There's contact points later on in the brief, and I think we may put it in the chat as well. And the training team, Brian Mata in particular, can help you prepare any materials that might need preparation for a talk you might give. Or Brian can also help you put your hands on training or product descriptions that might already be available that might be pertinent to your talk. Thanks to the TowerS team. It's been a very productive weather service, JPSS, GOES-R coordination. Kashad Bowman for helping the presenters and the facilitator prepare for this. Office of the Chief Learning Officer, GOES-R, JPSS, our facilitators, speakers, and of course you participants. Thanks to all of those. We are about to begin, but just a few words about Chad. Most of you know Chad already. He has a long-standing collaboration in many satellite topics and has done a lot of collaborative projects with the Office of Observations. We always appreciate his participation. Some background on Chad. He's a Techniques Development Meteorologist with the Science and Technology Services Division of the Southern Region Headquarters in Fort Worth. He develops, implements, and manages advanced techniques for preparing forecasts and warnings, with an emphasis on applying new data sets and technology to improve forecasts that drive NWS Decision Support Services. Chad, welcome back to the Satellite Book Club. Please begin as soon as you're ready.
Yeah, thanks, Brian. I appreciate the introduction. That bio is a little dated now because for the next year, I'm also the National Weather Service lead on the FACETS program. So FACETS is forecasting a continuum of environmental threats. And the great thing about the Satellite Book Club is ProbSevere LightningCast fits right in to the FACETS framework, which is great. But before I pass it over to John, we thought we'd do something a little different today. We're basically going to have, basically like a forum, right? Like just a discussion with everybody, and everyone will get about 5 minutes, and then we'll have some Q&A. For those of you who are out there, please utilize the chat feature in GoToMeeting. Talk about your thoughts, put any questions in there. If they're appropriate to discuss, right in real time, we'll interrupt, and if not, we'll save them for the Q&A. So the first person we're going to pass it over to is John Centennial. John is a research meteorologist for University of Wisconsin-Sims. He's worked on projects like fog and low stratus probabilities, ProbSevere, ProbTOR. He's also done some volcanic ash detection work, and LightningCast is one of the first or one of the latest projects that John's worked on. I was introduced to it about a year ago now, and it only took me a few days to be completely blown away. And that's what we're going to kind of discuss today. Some of the feedback, some use cases from Ted and Steve. So with that, John, I know you only have a few slides, but why don't you take it away before we we move along to Ted.
Yeah, thanks, Chad. Thanks for the opportunity to have this panel discussion. Looking forward to it. Yeah, I want to thank my collaborators, Mike Pavlonis of NOAA NESDIS STAR, Justin Siegliff of UW Sims, as well as Lee Krantz of UW Sims, who I forgot to put on here, but he's been instrumental in getting LightningCast into AWIPS, into a lot more forecasters' offices. And go ahead to the next slide. Right, so just really quick, ProbSevere LightningCast, it's a deep learning model. In this context, that basically means it uses images of ABI data to predict next hour lightning occurrence. And the way we define that is with GLM observations. So the target or truth data, what it's trying to predict is basically GLM accumulation in the next 60 minutes, and the field we're accumulating is the flash extent density, which I think most of your offices are probably familiar with. There are only 4 inputs, they're all satellite inputs. The 0.64 micron reflectance, channel 2, that's the red band, 1.6 micron reflectance, that's the snow ice band in the near IR, 10.3 micron brightness temperature, long wave IR window, and the 12.2 micron brightness temperature, which is the dirty IR window. So those first 3 channels make up the day cloud phase distinction RGB, which we know is really good aid in visually helping to pick out where lightning initiation may be. The 10.3 and 12.2 channels that also make up the split window difference, and that can help determine pooling low-level water vapor in certain situations. So the output of LightningCast is basically a pixel map. It's the probability of at least 1 or more GLM flash in the next 60 minutes at basically any location. And we run this on ABI CONUS sectors and the mesosectors for GOES East and West. LightningCast was trained on just GOES 16 data for all months of the year. I think it was 2019. But it is definitely weighted towards the warm season where you have more lightning observations. And I just want to point out that this has been published now. It's in the latest issue of Weather and Forecasting, so I invite everyone to take a look there if you want to learn more details. All right, go ahead, next slide, please. Okay, so we had a really cool opportunity to have multiple different mechanisms for getting feedback from the Weather Service. The first one was from the Ocean Prediction Center. They had a test bed in January and February, and that was really good and insightful. During May and June, we had the Hazardous Weather Test Bed where LightningCast was evaluated, and then with Chad and others helps through the Southern Region evaluation too. So these charts are just from the Hazardous Weather Test Bed. I wanted to share some initial feedback from HWT forecasters. So I'm going to start with the top right. We just basically asked, like, in general, what did you find the actual lead time of LightningCast to be in terms of predicting lightning initiation? And so each forecaster had 1 response per shift. So it was something like 80 or 90 responses. And almost half of them found that there was at least 20 minutes of actionable lead time. And one thing that was really interesting is that this matches really closely with what the OPC testbed found. We asked basically the same question to them about, in a median sense, they were finding at least 20 minutes of lead time. This also matches an offline analysis we did in the paper, where we found, again, in a median sense, we were getting 20 minutes of lead time to the first strike, so lightning initiation. And this was from the probability thresholds that maximized skill. So
Yeah,
it's really.
Before you go on, like when I read the paper a few weeks ago, I had that 20 minutes in my head and I knew about it. But then when I saw these slides like a few days ago, that kind of blew me away because those are completely separate. I mean, one's a very statistical quantitative assessment, right? And this is from all our users, like these 90 or so survey responses that found the same thing. And I was pretty impressed by that, and I was somewhat surprised how nicely, I was happy, but I was surprised at how nicely they they lined up.
Yeah, it was good to see just independent sources kind of saying basically the same thing. Now, it is a wide distribution. You can see from this graph, what, 36% is like 10 to 19 minutes. So, right, you're not going to get 20 or more minutes every time. It's in the median sense of a wide distributions, depending on the convective regime. Some storms electrify sooner than others. Some take a long time. So just keep that in mind. But it was really encouraging to see that they were all saying very similar result. In the bottom right, we just basically asked at the end of the week, like, how often would you use LightningCast if it was available in AWebs? And basically everyone said they would use it at least regularly. So that was super encouraging, and hopefully some ammunition to take to get this operationalized. And then in the bottom left, we just asked basically, what would you use LightningCast output for? We had a bunch of different suggestions, and the obvious ones, basically everyone said they would use it for, so IDSS support and convective initiation or maintenance, situational awareness. Most forecasters said they would also use it if they had to make TAF amendments, and roughly 50% also said that they could use this LightningCast output for airport weather warnings or even like severe convective weather situational awareness, which was interesting to hear too. So yeah, I think I've heard a lot from the OPC and HWT now, and I think we've been pretty happy with the responses, and I think a lot of forecasters are eager to use it more. So yeah, I'm interested to hear from Steve and Ted, and I'll let one of them take it away.
Yeah, thanks, John. So let's move over to Ted. So Ted Ryan has been in the Weather Service since 1998. He started in Corpus Christi. That's right, that's the 2000s for all of you out there, just to, nail that one in the coffin. In 2004, he moved to Fort Worth, where he was a meteorologist and then lead meteorologist. And then I think it was 2015 or so, he became the Science Operations Officer. And he's been the SU at Fort Worth ever since. So with that, Ted's going to show us an interesting DFW case on LightningCast.
So yeah, thanks for the introduction, Chad. The case that we're going to look at is a really interesting one, and I think it's interesting because when I go to the ops staff or the forecasters with a new tool, a lot of them will look at it and then decide if they want to use it right away or not. I think when you go to a hazardous weather test bed or OPG, you're there to specifically look at a tool. So I think the motivation to use it is really high. But out in the real world, you're going to have forecasters that flat out say they don't need something until you show them that the value is there. So when I first showed this tool to the ops staff, a lot of the veteran forecasters right away said, oh, it's going to show me there's lightning with that big thunderstorm. Yeah, I didn't know that. And in a sense, yes, that is true what it does. But what I really tried to stress was it shows convective initiation really well. And I think some of the veteran forecasters will then say, oh, I already know how to do that. I can see when cumulus is bubbling up, or I can look at the RGB and see that stuff. I said, well, this is, can be used for situational awareness. And then this case, what I really love about it was actually a case where I think it would exceed the forecast skill of even some veteran forecasters. And I was working this night, and I was actually training a very young forecaster that probably wasn't up to speed on how to look at satellite and see some of the clues. So I think that this is a great case. So let's go to the next slide, and we'll dive right into it. And the dilemma that we had, or the challenge that we had on this case, was we were doing TAFs for the Metroplex, the DFW Metroplex, which is one of the busiest airspaces in the world. A little geography overview here. You can see Dallas in the middle of the screen there. DFW Airport's a little bit to the west of Dallas, and between Dallas and Fort Worth. There's also Love Field, very busy airport, and Alliance, which is a very busy cargo hub. So the whole air traffic control system here is very important, and it covers just basically a 10-15 county area. So this convection starts coming in from the from the east, and what we were worried about was, okay, do we need to keep thunder in the forecast? Are we going to have thunderstorms at either Love or DFW, which would be our most important airports that we care the most about? And so I'm working with this new forecaster whether we should have vicinity thunder or even prevailing thunder in the forecast at this time. So let's go to the next slide. Obviously, you can just see from the radar that, you know, there's storms well out to the east. Its sunset is approaching. They're not going to make it in time, but is something going to develop? And so the satellite really starts showing some things here. The center of the screen there is Dallas County, and you can kind of see the LightningCast probabilities overlaid on the satellite. And what we see here, the LightningCast is really kind of arcing it toward, or kind of pointing toward the northwest, both towards Dallas Love Field and DFW Airport. That area had no radar echoes. A young forecaster may not really be able to key in on how important that cumulus field is looking and how it's developing. But what I really thought was interesting here is you look just to the south of Dallas County there on that bullet on the bottom part of the screen. We actually had radar echoes with that towering cumulus there, and you can see how LightningCast just really isn't interested at all with that activity. So let's go to the next slide, and we'll kind of step through the radar and satellite here in a little bit. So based on that LightningCast forecast at this time, again, TAFs are due right now. What we did was we retained the VCTS and the DFW and Dallas Airport, and we kind of thought that maybe 1 to 3Z was our target window. And again, that was based on more than 50% probability of GLM flash occurring in the TRACON area or just east of Love Field especially. So let's step through how this event evolved. So 30 minutes after we've issued those TAFs, you'll notice that those LightningCast probabilities are starting to increase across Dallas County. The sun is starting to set, so the cumulus still looks interesting, but maybe you wouldn't really be able to tell too well on this slide here. But because LightningCast is increasing, we're getting more and more confident that we're going to see some convection impact the airport. You can see on the radar there that the convection is kind of still moving east very slowly, but it's more important. What we really care about is the development. So let's go to the next slide, which I believe is 15 minutes later, and you can see the probabilities continue to increase here. And at this point, LightningCast is basically saying that there's going to be GLM flashes near or at the airport at Dallas Love Field, and the probabilities for DFW also continue to increase as well. If you look at the base radar data, you see that there's really no sign that anything's about to occur or that there's any development. I think if you looked aloft, you might see some developing radar echoes up there. But again, this is the situational awareness aspect of it. Even if you didn't know how to really, look at satellite in this manner, there's a tool out there that's flagging you down. Or if you're busy writing your aviation discussion or something like that, this is there to kind of, be that friend in your back pocket that will tap you on the shoulder and let you know that things are changing. So let's go to the next slide, which I believe is 30 minutes after this. So we're at 045Z now, and you can see that the probabilities in LightningCast are now over 80%. We're starting to get a little echo right over Dallas County, and you can see the development of the cumulus looks much better here, and you're starting to get this outflow boundary that's going to trigger more convection along this kind of little finger of cumulus and tower cumulus over DFW and Dallas. So let's look at the next slide, and here's just how the radar panned out over the course of the next hour and a half or so. This cell just continued to develop along the outflow, along that finger of cumulus. And although both DFW and Dallas did not report any rain with this, they both technically had thunderstorm on station with a ground stop needed at DFW. So next slide. Okay. And so what I really want to go back to is talk about this. This is where I think LightningCast adds so much more value that even perhaps a veteran forecaster might not know. And I think what's happened, and perhaps the developers can kind of correct me on this, but I think that reason that the LightningCast was so interested or bulged out to the northwest there across Dallas County was because that cumulus was kind of arranged in a pattern that was attached to an ongoing thunderstorm farther to the southeast. Even though there were radar echoes and there were towering cumulus also developing in the county just to the south, you notice that LightningCast just was not interested in that activity. And you can also see that even farther south, there was that similar kind of little notch or bulge in the LightningCast probabilities. And that was indicating that perhaps that line of cumulus or that finger of cumulus was also going to develop into convection in a little bit. And that is exactly what did happen. So I've seen these fingers of cumulus in this pattern. Over the years, I've forecasted this area for 15, 20 years now. And I've seen those fingers of cumulus, and when you have an outflow boundary come up there, it seems to be the area where you have repeated development, often a lot longer than the forecaster would traditionally expect. So I think that there are some forecasters that maybe have been forecasting in our area 5, 10 years that haven't caught on to that thing yet, or that little hint from the satellite data yet. And I think this is where LightningCast can really raise the bar and really help everybody, make a better forecast. In this case, me seeing the LightningCast probabilities, confirmed my suspicion that cumulus line was going to continue to develop. And so it raised our confidence into actually, forecasting and keeping the risk of thunder in the TAF forecast. So that's it for my case. And I guess we'll pass it over to Steve, unless we want to pause for any comments or any chat.
No, let's pass it over to Steve just for time constraints. So for those of you who don't know, Steve Zubrick is the Science Operation Officer at the Sterling, Virginia Forecast Office that covers the Baltimore, Washington area. Steve, I don't know how long you've been at the office, but probably longer than Ted's been at Fort Worth. But you've been involved with a lot of integrating probabilistic tools into the forecast process, including the winter weather probability products that I know that your office in Eastern Region in general really spearheaded years ago to get that expanded across the CONUS. So with that, why don't you take it away and show us your case, Steve?
Okay, thanks, Chad. And yes, I've been here quite a long time. I won't go into it. It's kind of embarrassing. Let's go to the next slide. So I just wanted to show that we've been interested in the LightningCast products this year. We took a slide that was presented at a workshop, I think in Southern Region or Central Region, and we actually had a couple of slides on LightningCast that we gave our forecasters during our spring severe weather workshops. This is just an example. Next. So LightningCast probability products, or LC, they were really used only by a few forecasters via the SIMS webpage. And we've been looking at this, probably, for the last year or so, just a few of us. And then this spring, I worked with Lee Byerly to get the products into AWIPS, and that really made a big difference. I experimented with some of the contour colors and widths, but we showed people, but we ultimately kind of went back to what the default values were. Worked with Donald Harrigan down in Miami, who helped with like the line thickness style rules. So for those sites that are getting this in AWIPS, I put a kind of a reference there for how, if you want to make thinner contours. But like Ted said, it was, it's one of those things where I've introduced a lot of new guidance products to the staff and over the years, and sometimes they take to it, sometimes it kind of falls out, but this was a product that basically sold itself, and the majority of our staff, I would say all of our forecasters, in fact, immediately began incorporating this guidance products anytime that they're concerned about, severe weather. So we actually, the note there at the bottom, was something I posted in chat on April 8th that we basically, that's this year is when we started installing the software and made it available. Next. So for the AWIPS folks out there, when you add this, we actually added it under the full disk GLM menu, and we actually changed the name from NOAA SIMS LightningCast products to LightningCast products NOAA SIMS, just because everyone here referred to it as LightningCast products. It made it easier for the forecasters to call it up. Next. So it wasn't very long, like just a couple weeks later, a forecaster came and showed me how they were looking at an area of storms. This was in early April. This is one of our first convective events this season. We actually had snowfall winter warning headlines through April 18th in our area. So this was our first kind of warm season event, and the LightningCast products gave about 20 minutes lead time, which is consistent with what John was talking about, that they saw in the hazardous weather test beds. And importantly, it raised the forecaster awareness of the developing storm that eventually became severe. So they were on top of it and were able to get warnings out in a timely manner. One thing that I show on this image here, though, is that if you look at the contours, there's kind of an elongation between a cell further to the south and the one that you see the yellow warning polygon on. This is a kind of a feature that many of the forecasters and myself have seen, where sometimes the contours, kind of stretch out and smooth things out a little bit. So, this was a cool season event, but I've also seen this in the warm season. I'll have another slide on this. Next. So just mentions and referrals to the LightningCast products. The first one at the top there was actually, we were using the SIMS webpage, and forecaster was alerting other people on our internal chat, that there was lightning showing up with radar echoes. The blue boxed chats there, 2 and 3, that was again pretty close to the time where I was installing it in AWIPS, but they were monitoring that, and the other forecasters were asking, where can we find it in AWIPS? Third cast was me and June, just noting how we start getting these 10% dark blue contours. That kind of is a heads up, that something's happening. And then the way it's working right now, these data, since they're experimental, they're not on the SBN satellite broadcast network for AWIPS, and so we get them through the LDM, through the data manager. So we get it from Eastern Region, and we did have a problem in the Eastern Region earlier this year where we lost the server up at Region. So we were without this data for many weeks until they could restore the server. So I took a lot of arrows from the staff asking me where the products were. So that just showed how good it was. Next slide. So this is going to be a sequence, and the white circled area is essentially the area of notice. And you can actually see some contours further to the east, but that one county that's kind of squarish, looks like a little boot on the end. You can see Comanche and DeLone cities in there. It's kind of tilted. This is going to yes, right where the cursor is. That county is going to essentially light up. So this is at 1436. Go to the next slide. It goes to 1441. There's still no contours there. And the one thing that I should point out here is that on the green bar at the bottom, the title bar where it says LightningCast East Conant 60-minute probability, and then in parenthetically it says PLAX-core. This is parallax corrected, and this is a huge thing for our forecasters, where these data are being corrected for parallax. So that is a big plus. Go to the next slide. This should be 1446, and now it's lit up, and you now see the 10, 25 in cyan, and then you see the bright green 50 highlighting the northern part of that county. Go to the next slide. 1451, still nothing showing up. Next slide. So at 1456, there were actually a couple of strikes at 1454 actually. So roughly you got about a 10-minute lead time on some of this activity, and you'll see a 75% contour there, which is giving added confidence that lightning is imminent. And then you go to the I think it's 1501 image. You'll see some GLM data, some Fed data that's lit up there, and you see a number of lightning strikes from the ENTLN, the ENTLN data that are there. So it's giving you solid 10, 15 minutes in this case. Next slide. This is an example. This is also from the early spring, and the white letters are kind of the states. It's hard to see the background a little bit, but I believe that the LightningCast does highlight some areas that don't produce lightning, and this was a case here. It's a known issue in the cool season, but I happen to see it even in the warm season. I can let people like John and others comment on that in the Q&A. But just be aware that just because you're getting these contours, it doesn't mean that you're going to essentially have lightning in those areas. The next slide, and I think this is my last slide. So basically, for the National Weather Service, Weather Forecast Office forecasters, having these products in AWIPS was really the thing that made it big, and it basically, it sold itself. It's routinely used by forecasters. Big bonus is that it's parallax corrected. And in our area, our experience is that it provides at least 10 minutes to sometimes 25 minutes or so of lead time on those first lightning strikes, and that's huge. And then, the one, maybe negative on it is that there are some false positives, but overall, those are not impactful to our overall forecast process. And lastly, I put a link in there that SIMS also produces these data in a form for those who have the GR2 Analyst software package for the Windows PCs. And there's a link there, and it's also on their webpage, where you can get these data and put it on your GR2 screen. A lot of forecasters here use GR2 as a supplemental aid, and they have this product on there. So I'll turn it back, I guess, to Chad. That's essentially what I have.
Yeah, thanks, Steve. So a lot of good questions, comments, Q&A. Why don't we we'll do some housekeeping, and then we'll kind of jump over to Q&A, just in case people have to drop off at the bottom of the hour. First things first, a week from today, Thursday, July 21st at 12 Eastern Time, Andrea Lloyd from USGS Aeros will discuss Landsat products for post-event analysis. So be sure to come to that Satellite Book Club if you're interested in that topic. And then, if you have any questions or comments, ideas for satellite book clubs, I know that Lee and John Evans and Kashad are all interested and are always looking for different topics. So feel free to contact them at the, you can see their contact information on the slide in front of you. So with that, let's start with some Q&A. So, there's a bunch of ways we can do this. I think, maybe John, you can kind of help me monitor the chat. But the first thing I want to talk about, which I thought was interesting about your two cases, was how different they are. So this is a question for Ted and Steve, but so Ted's case, it was basically shallow Q developing like you would see in warm season, convective initiation event. Steve's was very messy, a lot of mid-level clouds, developing convection within. And LightningCast was provided really good guidance on both of those, which I think is good, because we all know not all events are created equal. So I guess my question is that kind of what you all see, Steve and Ted? And anyone else who wants to share their thoughts in in the comments, do you feel like LightningCast, for the most part, I know that there's different skill in different seasons, but for the most part, it handles different types of convection just as well as another type?
I'll go ahead and answer that. Because we have different, scenarios and synoptic conditions, like you said, it's a little messy here. Sometimes, we get a lot of, clouds that are not just bubbling Q and things like that. It's a more embedded lightning. I think, using all of those different channels, it is sensing, where you're starting to see some hot spots there. I think it's excellent for convective initiation in warm season. It does tend sometimes to broaden out the contours, that they go over areas where maybe there's not much going on there. That that could be something that the developers maybe look at or have looked at. But But overall, it's the contours are bright enough that you can put it actually on a situational display, you know, in AWIPS if you have one in your office, and just have that loop going. We have a big screen that we can put any AWIPS screen up on there. And what I find in the summertime is forecasters are putting, you know, some type of satellite image up along with the LightningCast products, you know, because those contours show up pretty big, and so you can kind of keep an eye on things to watch it develop. So it's I think it does really well with convective initiation.
Okay, thanks, Steve. Before I pass it over to Ted, because I'd like to hear his thoughts. You know, that's some feedback that we got from one of the CWSU Mets in Fort Worth, who gave us some formal feedback, is they actually display this on their situational awareness screen in traffic management unit. And the TMUs use it along with along with the Mets for situational awareness. So, which I found really interesting, because that tells me that even someone without any kind of meteorological knowledge can still identify, you know, where things are starting to potentially bubble. Now, they may come over and ask the Mets, and I'm sure they do, about what they think about what's going on, so they can add some meteorological insight, right? And some added, you know, value there. But when I read that feedback, I was pretty surprised and happy about that. So I just wanted to say that, because you reminded me of that, Steve, about the situational awareness, you know, display. Ted, what about your thoughts? I mean, do you think that LightningCast handles different types of situations just as good
Yeah,
as ordinary convection?
Yeah, I really do. I've seen cool season and I've seen warm season. I think it's really good in the warm season when it comes to convective initiation. And what it's really good in the cool season, I think, is for situational awareness. When you have a lot of synoptic clouds and it's very messy, I think it excels at you know, where a human could identify where things are starting to bubble up. So yeah, I haven't seen a situation where I felt like, oh, it's really not, you know, doing good today, or it doesn't know how to handle MCSs, or, you know, I have not seen any weather situation where it doesn't know what to do. What we do have the ability to do as humans, though, is if we know the environment, because this is not using any environmental data.
Right.
If you know your environment is primed for, you know, convective initiation, warm season convection, you can start using the contours differently. So like 10 to 25% when you know you're gonna have storms soon, you can actually start acting on that right away. And the messier cool season high cloud type events, it's a little different, where I like it for situational awareness. I just put it up on my satellite display, it's on there. Sometimes storms form when you're not expecting, and I'll be sitting there working on something and I'll see suddenly the LightningCast is going 10, 25. I'm thinking, okay, what's it seeing? And it draws me to what's going on. It has alerted me in the past that the forecast is about to go off the rails and need updating. And we're not just talking about, you know, IDSS specifically, do I need to issue a product or not? We're talking about just a broad scale sense of how the forecast is doing, and LightningCast is providing that lead time for me to get ahead of that convection developing and those types of situations as well.
See, yeah, so I want to pass it over to John. I have two questions, one from the chat. Before we get to that one from Steve Cobb, let's, you know, you kind of allude to in the paper, especially at the end, I think it's in the conclusion section maybe, that, you know, this is like almost like a first step, and you all are open to investigating how maybe MRMS data or the environment can enhance LightningCast. I'd like you to comment on that and like maybe add a little more. I mean, LightningCast is so reliable from a probabilistic statistical standpoint that I will be shocked if it like these other data sets add a lot. But again, that's me. And one of the reasons why I say that is because as of right now, LightningCast works over the whole full disk, field of view, which is really important for, Ernesto in Puerto Rico and like in Brazil and other parts of the GOES kind of like, field. So I guess I'd like to hear your comments on adding additional data and if it's going to be valuable enough, et cetera. And then I have another question for you.
Yeah, there is a nice, I don't know, beauty in being simple and how it just uses the GOES data to make predictions, so it's consistent, fairly consistent anywhere on the disk. And actually, this all started with a collaboration with Ocean Prediction Center.
Right.
So I mean, I think there's always going to be a satellite-only type product. Now, if you were to add some environmental information or radar information over land, like, yeah, you probably can do better in certain situations. But again, it's all about trade-offs. You're increasing your complexity, but how much additional skill or lead time are you also adding? And so I think there's definitely more we can do with this, but I think everyone at Sims we were a little surprised at how well it was doing with just 4 satellite channels. And even just a satellite only model, I think there's more we can do. We're still evaluating other channels on a more seasonally diverse data set. We're finding some other channels are helping, like the channel 11, the cloud phase IR, and a few others. So I think we might add a few more channels eventually, but we have to do some more evaluation there.
Okay, cool. And so here's another question. And I don't remember the exact probability range in the paper that you guys found most skillful, but
Yeah.
but Steve in Tulsa and Steve Zubrick, they seem to be finding that the 50% contour is pretty useful on eventually seeing lightning strikes or a GLM. Can you talk about like that part of the the probabilistic
Yep.
space? Yeah, go ahead.
Yeah, so you can pretty readily see what probability threshold optimizes something like CSI, critical success index. And I believe overall the 40% threshold was the that magic threshold that optimizes CSI, which is close to the 50%. That's the closest contour. So I'm not surprised that folks are finding 50% is kind of the best contour. Now, the other thing, and I don't know how many forecasters know this, but you can easily change these contours in AWIPS. You can change how many, you can change what probability level they appear at. So you could put one, change to 50 to 40 if you want, and just have like 10, 40, and 75 if you want, or you can change the colors and thickness as Steve alluded to. So we just picked these 4. I think we actually picked these before we knew what the best probability threshold was, and 50 is just kind of a nice even number. So yeah, that jives with what we've seen to answer Steve's question. Yeah, I just wanted to address Ted's example. I think his hypothesis for what's going on with those bulges of LightningCast probability, I think it was spot on. So this model is kind of this type of model. This is the best automated way we can take spatial context of data into effect, and in this case, the satellite data. And I think, yeah, just the fact that there's stronger storms nearby and that there's more kind of in those little lines like congested. There's more congestion of Q. I think the model is definitely picking up on that. And there's ways we can test this offline to say, oh yeah, this is why the model is making the higher prediction here versus that cell to the south that it had very low predictions. So that's something I might go ahead and test soon, and I can share the results with Ted in his office at least. But yeah, I think what you're seeing is right on.
Yeah, I had a follow-up and it kind of lost me. Well, you know, I've been Mike Pavlonis left a comment about, you know, the IDSS stuff, and Matt Foster, you know, did that as well. I think it's interesting. I mean, like, so right now, LightningCast is being used for the World Games in Birmingham. They contacted me and said once things calm down, they're going to kind of share that feedback.
Oh, yeah.
Yeah, go ahead, John. And I remembered what I was going to ask.
Oh, no, good. No, I'll be interested to see what, how Birmingham's been using it. So.
Yeah, me too. And honestly, I haven't paid attention. I don't really know how much convection's been down there the last.
They've had quite a bit. They've had to postpone some events. So.
Okay, great. So that should be, yeah, it'll be interesting to get that feedback, and maybe we can do another satellite book club down the line. My question is, before we wrap up, because we do need to wrap up, what is some of the negative feedback you guys get? Like, if there was like, if you can think about like, what's the one thing that forecasters struggle with? And I ask this because, and I don't want you all to think that this is really good. Everybody should be using this product, in my opinion. If you're not, you're just doing it in service to yourself, because it just makes your life so much easier and you can provide so much better service. That's my opinion, world according to Chad. But what is some of the negative feedback that you hear, John?
Yeah, I mean, I think Steve alluded to it a little bit. There's a little bit more of an over forecasting bias, more so in the cool season, but yeah, it does happen in certain situations, and in the warm season, and that's something we're trying to improve. The other thing we saw is that, right, it just uses satellite inputs, so it can't really see what's going on under a really thick ice, anvil that's really expanded. If there's convection happening under there, it's gonna have probably lowish probabilities until it starts to see some towers poke out of the cirrus shield. So in those situations, you might have a relatively low lead time, depending on how vigorous that convection is. So yeah, it's not a perfect model. I think it's a pretty good first stab, but yeah.
You ever get feedback that, because people struggle with this, when I've heard that the probabilities are too large, and I know why that is, right? And I understand it's mostly about the GLM footprint, which it's trained on, is big, right? So, there's part of that kind of plays in. But do people ever complain about this, even an isolated convection, the size of those initial, maybe probability rings around that area of Q?
Yeah, that is something that folks have pointed out.
I could add something to this. I think the biggest complaint is that it is GLM. It's in cloud. It's not necessarily a cloud to ground strike. And when we're doing things like airport weather warnings or IDSS for emergency managers, they may not care if there's probabilities for in cloud flashes nearby. They really want to know, is it going to be a cloud to ground strike near them? That's going to be the issue. So those large probabilities and training it on the GLM, I think is great, because it helps get more lead time. And so the negative part about that is you can't use a contour all the time. You can't always say, I'm going to issue an AWW and it says 40%, because 40% with developing convection, issue the AWW. 40% with maybe some mature convection that's kind of well displaced, and there's a big anvil shield, and yeah, you're going to have some GLM flash, or most likely in cloud activity nearby. You're not necessarily going to have a cloud to ground strike, which an AWW is verifying off of. So sometimes I think, well, why not just train it on CG flashes? And then I would realize, well, you would lose a lot of the lead time component for convective initiation. You would run the risk that you're going to have a lot of CG strikes and very low probability contours, and I don't think that's desirable either. So I saw a question in chat about MRMS. I think this beats the pants off of MRMS, but I'm not saying that MRMS doesn't have a place, because MRMS can be a little bit more high resolution once a storm does develop. So there's that advantage using both data sets there.
Mm-hmm. Yeah, I mean, basically, if there's a chance of lightning, there's a chance of CG lightning,
Yeah.
but right, there's higher chance of CG lightning if you have already some in-cloud lightning. I mean, typically, you start with in-cloud lightning. So yeah, I think forecasting a probability of CG is definitely more difficult. Might need to bring in some other data, but maybe you could get something close if you just start predicting, probability of 5 or 10 flashes or more, basically a higher lightning threshold, then there's going to be a greater chance of CG. But
Yeah.
yeah,
And
that's a good point.
yeah, and with that, I need to send it back over to Brian Gockel. Brian, on behalf of myself and Steve and Ted and John, thanks for inviting us. I always love to do Satellite Book Club, especially when we mix it up and do something a little different like today. And I hope everyone out there found it as interesting as I did. I like this one because it takes the product and we get some end user feedback immediately, and we're all kind of in there together, talking about things. So we appreciate it, Brian.
And as do we here in the Office of OBS, appreciate very much, Chad, that you and the other presenters today, Steve, Ted, and John, gave us this presentation, which was very, very informative to me, and I'm sure more importantly to the forecaster community. I did not fully understand the potential of this utility, and I'm now more educated on it. I'm interested in seeing how it evolves. And we really appreciate hearing from this group of four with an impressive body of knowledge and authoritative experience in this area. So thanks for putting these materials together and bringing it to the book club. On that note, we'll wrap it up with just a quick reminder. As Chad mentioned a few minutes ago, we've got the next Satellite Book Club seminar series 1 week from today at the usual time. Andrea Lloyd from the EROS Data Center will be giving us a Landsat presentation, and I'm sure many of you, if not all of you, will want to hear that. So we'll see you in a week. Thanks for your participation. And the seminar series, the seminar today is wrapped up. Have a great day. Thank you.